In this video, we're going to demonstrate how to measure a cylinder, and we do that first by beginning with a micrometer. And we set the micrometer to the specification of the diameter of that cylinder. So once we get it set and locked, then we'll lightly clamp that into a vise using a rag so that we don't distort the micrometer at all. And again, just lightly clamp it in, not tight. And then we'll use a dial bore gauge. In the dial bore gauge, you'll want to pick the attachment that most closely fits the diameter of the cylinder we'll be measuring. In this case, it's the 4-inch attachment. And we've determined also that we'll need a little bit of a spacer. And so there's some spacers that you can choose from. Now this dial bore gauge has a dial indicator on it, and dial indicators don't measure anything, they only compare two measurements. So the very first thing we need to do is set this dial indicator at 0 for the measurement that should be the perfect specification for the cylinder. And so what you do is place the dial bore gauge in the micrometer, hold it on the back, and then rock it back and forth. As you rock it back and forth, there will come a point where the dial indicator is turning around, where the actual needle is reversing directions. See right there where it's switching? And he's going to adjust that until it's right on 0. Right about there, perfect. Then we'll pull it out. Now we'll bring that dial bore indicator over here to our cylinder, our simulated cylinder. And first, what we want to do is we're going to measure taper and out of round in the cylinder. And so we'll need to take 6 measurements total, 3 around the top and 3 around the bottom. But we'll start by measuring right here. And he places the dial bore indicator in the cylinder about 1/2 inch to 1 inch down, but near the top, and he'll rock it back and forth. And we're watching to see where that needle changes directions. See, it's right there between the 6 and the 7. Now, the 0 is up here on top, and everything to the left of the 0 means it's larger than the specification, and each whole number on this represents 1/1000th of an inch. And so we're actually about 3.5 thousandths of an inch larger than our specification here. So it ends up being 3.5, right? Or is it 3.6 thousandths of an inch? Or 3 thousandths and 6/10 thousandths, however you want to look at that. Now we take the dial bore gauge and go straight down, so directly below where we measured, and take another measurement, another reading. See, in this case, let's see here, right there, right, this moves around a little bit because this cylinder isn't exactly true. Right there, if that's where it's turning around, is on that 5, that's 5 thousandths of an inch larger than specification. And we compare those two readings, the top and the bottom, and that tells us that it's tapered about 2 inches, right? Or 1.5 inches, or 1.5 thousandths of an inch of taper from the top to the bottom of the cylinder there. Now we take that dial bore gauge and we do that same measurement. We repeat ourselves 3 more times. We do this at this angle, and then we'll do it at this angle, so that we divide the cylinder into thirds basically. We'll take a top and a bottom measurement in each of those positions. We'll record those measurements. Now keep in mind that on this dial bore gauge, every small notch on the gauge represents a 1/10,000th of an inch. So it's a very precise gauge, and the big numbers are thousandths of an inch. But what we do is we compare the readings. The top to the bottom readings will represent the taper. and we'll get 3 different taper readings, one from each of the positions we measured in. The largest of those readings we call the cylinder taper. And then as we take the 3 readings that we took around the top of the cylinder, compare those to each other, and the difference between the largest and smallest of those 3 readings is the cylinder out of round for the top of the cylinder. And then we do the same thing with the 3 readings that we took down near the bottom of the cylinder. And then the biggest of those differences, the largest number we come up with, is the cylinder out of round. And finally, with those numbers, the largest number that we read overall is the cylinder bore diameter. So that we take the biggest number we came up with, and that's what we'll call the diameter of the cylinder. We compare all of those numbers to the specifications to determine whether the cylinder can be reused, whether it needs to be bored, and we need to bore to a larger size and buy larger pistons. That's how you measure a cylinder.